Alright, there's another video for 3VT, and this time it's about exercise 73. The dike shown in the figure is prism shaped, and this is a prism, right? It's a three-dimensional shape. We need to calculate the volume of this dike, so we need to calculate how much, what the volume is. Right, so we know a couple of things. We know that this length is 3, we know those angles, and we know that this length is 9, so that's something important to know. I'm also going to write that down over here. And we know that the whole length of this dike is 7.5 kilometers. So they did this because they couldn't draw the whole dike, because this is 7.5 kilometers long. So then it would be a really long picture. So that's what this means, is just bigger than shown over here. So we need to calculate the volume of the dike. So if you want to calculate that, then we should know the area of this shape, of this trapezium, because if you do the area of the trapezium times the length, then you know the volume. So we need to calculate this area. So I'm going to split this area into a couple of different areas, because here we have a triangle, a rectangle, and a triangle, and those are easier shapes to calculate the area of, and then we can add them, and then we have the whole area of that shape. So what we see over here we see 38 degrees, right? And this is 9. Well, if this is 38, then this angle over here is also 38, because this is a Z angle. And in a Z angle, that means that those angles on the inside are the same. So we're going to use the 9 and the 38 degrees to calculate what this length is. Alright, so I'm going to calculate that length. So this is the opposite side, and we already know the hypotenuse. That means we have to use the sine. So the sine of 38 is the opposite side that we don't know, divided by 9. So if I do 9 times the sine of 38, then we get 5.54. So that's what this angle is, or this side is over there. That's 5.54. Now if I want to calculate the area for this triangle, I also need to know what that length is. So I'm going to do the same thing, but now with the cosine. Because with the cosine you calculate the adjacent side, or the hypotenuse, but we already know that one. So now we have the square root, the question mark, divided by 9. So if you do 9 times the cosine of 38, then we know how big that length is. And then we get 7.09. Alright, so we know this length, we know that length, we know this length already because that's 3. So the only thing I still want to know is what this length is, right? Well, this angle is also 18 degrees because we also have a Z angle there. And I want to know the adjacent side, but I don't know the hypotenuse, but I do know this one, so we're going to use that. Okay? So the tangent is what we're going to use. The tangent of 18 is the opposite side, which is 5.54, divided by the adjacent side that I don't know. So we're going to do 5.54 divided by the tangent of 18, and then we have the adjacent side there. So let me see if I can quickly find how big that is. That's 17.05. Okay, so now we know all the lengths that we need in the picture. So now we're going to calculate all of the areas. So I'm going to call this area 1, I'm going to call this area 2, and I'm going to call that area 3. Let me make another line because it was not very clear. For area 1, let's say a triangle, so you have to do a half times the side times the matching height. So a half times 17.05 times 5.54. And then you have that area. For area 2, we need to do, well, area 2 is just a rectangle, so 3 times this length, and that length was, what was that length? Did we count? Oh yeah, wait, 3 times 5.54. Yeah. So you calculate that. And then you have the second area, and for the third area, that's a triangle again, so it's a half times this length, which is 7.09 times 5.54. And then you have all 3 of those lengths, and then you're going to add it, and when you add all 3 of the lengths, you're going to get 83.51 squared meters. And then we want to know how much the volume is. So the only thing you have to do now is take the area, so 83.51, and multiply it with the length of the dike. And the length of the dike is 7,500 meters because it's 7.5 kilometers long. So if you calculate all of this, it would be nice if you just keep all the decimal places in your calculation, so it's the best thing it can be. Then we get 626,378 cubic meters of sand. And that is the answer for exercise 73. So again, a very, very difficult exercise. Yeah. So I mean, I understand that by this point, I mean, some people that are not very good at maths, they might not be able to do this whole exercise. And people that want to do Maths B next year, well, they'll probably won't have so much difficulty with this at all. Right? So thank you for watching. Bye-bye.